Hello and welcome everyone to one of the final moments of our conference. The aim of chaos engineering at its core of it is always to reach reliability and resilience, and this talk is just about that, where Michael teaches you how to configure Kubernetes for reliability with a tool set called LitmusChaos. Michael Knyazev is a DevOps consultant at TPG Telecom with 7 years as DevOps or SRE and certifications like a professional AWS certified DevOps engineer, certified Jenkins engineer, CKA, RHCSA, HashiCorp Terraform Associate, and more, and 15 years of experience as a software engineer. And who better than him to talk about this? So, with that said, the stage is all yours.
Thanks so much, Sayan. So let me share my slides. Just a second. Yeah, so I hope you can see my slides. Can you confirm?
Yeah, we can see your slides.
Very nice. Yeah, so it's about configuring Kubernetes for reliability with LitmusChaos and other tooling. So let's get into the first slide. Ideally, we want chaos and reliability testing to become a first-class citizen of our CI/CD process. It's because we want to regularly verify that our systems are reliable. With chaos engineering, we deliberately break or try to break something in our infrastructure and measure the outcome as it goes. At the same time, the chaos tests are traditionally time-consuming and are potentially not safe to run at arbitrary moments. It's because the entire system can actually become unhealthy. So we want the process to be automated and triggered when we are ready. Plus, we want to collect all the logs to let quality experts reconstruct the sequence of the tests and other important events after the reliability pipeline completes at their convenience. LitmusChaos can be used in a number of forms. It can help us a lot with chaos engineering. You can use the Chaos Center to manage all the aspects of chaos engineering and related collaboration right in one place, the portal. However, you can also use just the Litmus core to perform the core chaos engineering activities. I mean, trying to break components and then measure the behavior of the systems under test. I'm actually personally planning to use Chaos Center more as it goes because it's just convenient. So far, I have been using Litmus core quite successfully and happy with it. I am orchestrating the breaking and observing components right with Argo Workflows. Argo Workflows is a popular choice of orchestration of task containers in Kubernetes. Just to give an example, it's the heart of Google's Kubeflow platform for machine learning orchestration. This slide shows how all the tooling for reliability pipelines can be deployed into the target Kubernetes cluster. We can reuse the same cluster. We don't need to provision a dedicated one to save costs. What we need is the so-called tools instance. It is shown on the left in the diagram. And it will be isolated from the other workloads via standard Kubernetes taints. I will comment on that more later. That worker node will be needed just for the duration of a reliability pipeline run and can be decommissioned after that to save costs. I have open source plenty of reliability pipelines. You can use them as the blueprints for your own reliability pipelines. Some of them help verify resilience of microservices in the adverse conditions of a deleted workload pod, scaled out replicas of workload, and, for example, death of a worker node. There is a course on Udemy which explains how to configure system Kubernetes components to make the overall solution resilient. If interested, just Google for the name of this talk and you should find it. The reliability pipelines are 100% Kubernetes native. They can be triggered in a number of ways. Just to give an example, on this screen you can see how Jenkins can be used to trigger such reliability pipeline. The course Configuring Kubernetes for Reliability with LitmusChaos has a lot of details in terms of the testing tooling configuration, as well as configuration of system Kubernetes components for resilience of microservices. For example, I'm showing how you can conveniently use advanced LitmusChaos probes for reliability verification. Here are some slides. I am not able to fit everything into one presentation. So yeah, some of the bits which I described there. So this concludes the first part of my presentation. The second part goes into the technical details of the reliability pipelines implementation. And we are going to have the Q&A session right after it. So now, please kindly play the pre-recorded video explaining the details of reliability pipelines. They are all defined in that repository. We are checking it out into demo, dash, and corresponding postfix. This is a Jenkins file. It allows you to choose the reliability pipeline to run. And Jenkins is using pod, basically for Jenkins agents inside the Kubernetes cluster on the tools instance. There are stages init, reliability tests, reliability pipeline verdict, and results. Just 4 stages. In init, we check out all pipelines. And optionally clean the previous results. Then in reliability test stage, we run the Argo CLI script. The base image is tools, so it has Argo CLI installed. In the verdict stage, we are getting the result and decide what to do, pass or fail. And then in the results, we either keep or drop them, basically. And the first reliability pipeline we will run is pod delete. Let's have a closer look at its implementation. It's implemented as an Argo workflow. There are parameters, so we specify the target namespace and label of our basic microservice. So a basic microservice in apps namespace. Chaos duration is 32 seconds. The identifier of the Litmus experiment we define. Pod del, and we need to specify not select and tolerations because we want this pipeline to run on the tools instance in our cluster. We specify corresponding toleration. So first step, we are running pod delete Litmus experiment. We have HTTP probe in it. We pass which URL we call. And template for the Litmus pod delete is defined in the kube course repository. Let's have a look. It's under reliability, Helm, charts, templates, steps. Step 1, it defines the workflow template. And here you see the implementation of the template, the Chaos engine. We are targeting corresponding microservice, and we also specify tolerations to run on the tools instance. We are choosing pod delete experiment, HTTP probe, Litmus HTTP probe. Mode of that probe is passed from outside. We are specifying probe timeout, interval, retry. There are parameters we are passing into this experiment. This step 1 defines await Litmus result module, which is specific to Argo, so it's searching for corresponding chaos result resource and just streams logs of that experiment. So we will be able to see it in Argo. And this one is reliability verdict. It's quite important. Role reliability verdict. So it will allow our Jenkins pipeline to wire it up from Argo to get a result from the workflow. There is implementation of Litmus specific reliability verdict. This script, it looks at chaos result, and depending on the verdict of Litmus, it fills corresponding output of verdict, the output parameter in Argo. So we populate this basically chaos result verdict to outside via corresponding output parameter in Argo. We are looking into the chaos result and decide what to do. If the verdict is passed, then our verdict is reliability okay. Otherwise, it's not. We will see other types of reliability verdict later in this course. Let's have a look into the reliability pipeline. Yeah, so first we are calling pod delete experiment. We are removing the only replica of the microservice, the only pod. Then because we have this dependency, the block wait one pod delete, it executes after. So we will be able to observe streaming logs of the chaos experiment. And we are linking it all via this experiment ID, which is shared by all these nodes, observing the same experiment, the same instance of Litmus experiment. After this wait completes and the chaos result is populated, we call Litmus reliability verdict, and it gives its judgment if reliability is okay or not. Now let's execute our first reliability pipeline. So we are on our container, we type Jenkins, which is a function, and it will give us corresponding link to Jenkins as well as credentials to use. And on the top, I have prepared the link. It will be attached to the lecture. It's publicly available collection of reliability pipelines we will use. So let's open Jenkins UI and authenticate according to the credentials we have. This is the password we use. Oh, it's already filled for me. And now we just need to copy this link to the public repository with reliability pipelines. We go to the left in the Jenkins UI, new item. Let's choose some short name like R from reliability. And now we need to choose multi-branch pipeline and tap OK. It will ask us to configure this reliability pipeline, and we want branch sources, add source, git, and enter the repository URL we just copied. And now we just save. Jenkins starts scanning corresponding repository to understand which branches are defined in it. And you remember we have this Jenkins file. And if we switch to R now, we see the main branch. It's already trying to run Jenkins pipeline on the main branch. Let's go to console output, and normally it would stuck. It's a known issue of Jenkins that sometimes first run is not successful. So we need to cancel the first run of Jenkins pipeline like this. If we refresh, we can choose build with parameters, and we have corresponding options we have in our Jenkins file. this pod delete. So we are choosing it here, pod delete, clean policy keep, clean results before run, yes. And we start running it. Let's go to console output. And we can observe what's happening. So basically, Jenkins automation server is starting responding agents as pods in our cluster. They will be scheduled on the tools instance. And our experiment will try to kill the pod. Yeah, it's running. Let's wait a little bit and see. It will take some time. Right, so our Jenkins pipeline, the link is already available, so you can tap it. And this is Argo UI, which shows our workflow running. There are some containers being scheduled right now as we speak. This Jenkins UI has logs of the Argo workflow streamed into it. Let's have a look at the wait pod delete, because it gives us details of corresponding chaos experiment running. We see it's identified the target basic microservice, and it's about to kill the only replica of basic microservice, the only pod. Right? The age now is 57 minutes. And it's being terminated. And there is a replacement pod with age of 10 seconds now, because Kubernetes deployment has started it. And termination is happening gradually because we have lifecycle hook. The replacement instance is already running here. But there was a moment when no replica was available, and that's why at least one failure of the probe has happened. So we will expect this experiment to fail, because when there are no pods, it's impossible to serve the user requests from the HTTP probe. Right, and Litmus reports correspondingly. There is a smiley that check hello works probe has failed. So it's fair. It's fair. And let's see how this Litmus chaos result gets propagated via Litmus reliability verdict into our Jenkins pipeline. Reliability is not good enough. Yeah, expected. It's fair. And if we go into the Jenkins pipeline, corresponding verdict fail. If we switch to stages view in Jenkins, it's in red because verdict failed. Thanks so much. So you see that we tested our test, so to speak, and reliability pipeline is working as expected. But we also identified that our basic microservice it's not reliable enough in those circumstances. And you can imagine that the first intuitive step is to increase number of replicas, have at least 2 of them. And for example, as the course and reliability pipelines evolve, you will see that you want to place them in different availability zones to, cater for situations of full availability zone, unavailability actually, and other bits. So there will be many other things covered in that open source repository with reliability pipelines, and all the open source source code for infrastructure you saw, it's all linked from that Udemy course. So if you're interested, again, Google for the name of this talk, and you should see there are plenty of students who are already digging through this reliability journey. Thanks so much. So maybe now, if there are some questions, I can see actually.
Yeah, thank you
When it, mhm.
for the talk, Michael. There are a few questions actually on the Q&A tab. So we can start from this one. Um, where do you see chaos engineering getting adopted more in the future? Ops, CI, CD?
Yeah, I believe and it is suggested by such tooling as Spinnaker, for example. You want sort of fully prepare environment, perform not just CD, I mean continuous delivery, but continuous deployment, right? So you after the deployment in some environment like pre-production or QA environment, which sits in between the developers' environments and actual production. And in that environment, I can see that we run reliability tests. Of course, it should be balanced. I mean, time-wise, depending on the criticality of the release, because some reliability tests they can take long time. So you need to cater for that. And if you want to release a hot fix, for example, you don't have 1 hour to run the full suite of your reliability pipelines. But normally, if you can afford, you should do that. At least some basic resilience pipelines should execute. But the system should be deployed, right? In pre-production environment, it's the ideal place as I see it practically. As mature as these practices mature in companies, and it's safe from PI and safety compliance points of view. It can even expand to production, but of course it's not a requirement, and I would say it should be extremely mature, and there are the practices of chaos engineering. I believe it's practical for maybe like 15 companies in the world, if I can say so, because not everyone can afford this, because the level of maturity they have.
Yeah, totally agree. I think the audience would take this input and really put it across their businesses. Another question is, what improvements do you think chaos engineering and CI pipeline still needs?
I would say support of tooling and integration with other technologies, which are standard Swiss knife of any DevOps engineer. So look at Terraform, for example. There is enterprise version of Terraform, but also it's highly convenient, freely and open sourced, available binary, which can be used and integrated as a tool in Bash scripts, whatever. So this flexibility of tooling, but still Terraform, right? So this flexibility of tooling is very important. And what is nice, I can see it with Litmus. So there is Litmus Core, which is fully supported component to integrate wherever you like. For example, in Argo Workflows or in just Bash Shell, depending on the orchestration needs. But there is also Chaos Center, which is an addition to Litmus Core, and basically it follows the microservice architecture, which is quite rewarding for the community. So depending on what you need, you can use it and benefit from it and contribute to community, as I did, for example, open sourcing the reliability pipelines around Litmus Core.
Yeah, sounds great. Sounds good. All right. If you have more questions for Michael, I have actually created a thread on the Chaos Carnival 2022 channel on Slack. And I've also tagged you there. So, Michael, you might have also got a notification. So, feel free to ask your questions there, and he will be happy to answer them for you there. Is there anything
Sure
else?
thing. Yes, of course.
Yeah. So, is there anything else you want to add, Michael?
Yes, thank you so much for attending this session. I believe plenty of people which will watch it recorded So you are welcome again to Google for the name of this talk, and you will find the Udemy course. Unfortunately, it's not 100% free because Udemy doesn't allow courses more than 2 hours to be free, but it has the minimal possible price, so the price of burger. So you are welcome to. Yeah, if you can even actually write to me in the Chaos Carnival, and I'll arrange special code for free access to the course to you. Yeah, but Udemy platform is nice, so you can, after completion of the course, you can have the certificate of completion and share it in your professional networks. So yeah, and there are questions and answers and quizzes in the course. Plenty of resources, including in textual form as well, because some people they have trouble, understanding all accents of English. So there is a lot of documentation inside, including manually created subtitles. So yeah, you're welcome. So I'm happy to contribute to spreading the knowledge about reliability and resilience.
Yeah, I guess you can also share the link to the course on the Slack thread so that people who are redirecting there, they can also find it and maybe they can also keep it handy. So yeah, thank you once more, Michael, for this amazing talk. And this is also recorded and will be available on demand, so you can revisit it whenever you have it out or you want to just learn about the pipeline. So yeah, thanks for doing this, and we are going to have a closing session very soon. And thank you again for joining this session.
Yeah, I'll certainly follow up and place that link into the Chaos Carnival chat on Slack. Thanks so much for pointing. Yeah,
Thank
it
you.
was awesome. Very, very good experience of conference. Thanks so much.
Thank you. Have a good day. Bye.
Bye.